by the second question?
Well, it says what interest
You
rate?
did it for question. You mean like the effective interest rate?
So it was similar to what interest rate do you use? Well, if it's annual, you use 6%. If it happens 2 times a year, well, I gotta take 6 divided by 2, I'm using 3%. If it happens 4 times a year, I'm doing 6 divided by 4, which is 1 point. All I was looking for is this number.
I put it in the equation though, so.
That's fine.
I still have the number.
And you did more than you needed to. All right, first question. Any of those equal to that?
30.
Which ones?
The first one.
First one is.
First one is.
The second or the last one?
Last one is.
Last one.
The third
And-
or the second to last one?
The third one's not. Wait.
Third one is 1.1 squared is 1.21. So that is fine. This is the one that is the oddball. 50 times 50. And where they're trying to get you there, they're thinking, oh, you'll just add them together, right? 50 plus 50 is 100. Well, if you multiply these and get 100, you can't decide, oh, I'll switch it and add, right? You have to multiply. And again, you could just type those into Desmos on your calculator and check them, see if they're the same. Question 2. Georgia, would you read it, please?
Sure. From 1790 to 1860, the United States population is modeled by the equation P equals whatever, where T is the number of years since 1790. How many people were living in the U.S. in 1790 and 1860?
All right, so when you have these problems, guys, you have to be careful of what is it labeled in, right? It's in thousands. So there wasn't 4,000 people in 1790. There was 4,000 thousands. And again, that's where it can get confusing, right? It's 4,000 times 1,000. So if it was me, I would take the time and just write 4 million people. I think that's easier than having to remember, is that in the tens or hundreds or thousands? So there's 4 million people. Okay, so keeping that in mind, we'll use their equation. What do I use for an exponent?
T, years.
I'm looking for a number, though.
Is it how many years are from?
70.
No, you don't need a number in the first.
1860.
For,
Right, so 4 million people is this answer,
60.
right? Because that's what it tells me in the problem. So how many years is it from
70.
1790 to 1860?
70.
70. So type that in.
Don't we need to find how much is in 1790 then?
We ever use, oh, it tells us in the problem, 4 million.
Oh, true.
You ever use decimals? I just don't want to use decimals. Let's make it easy. It's already an easy calculator here. Because they interrupt your drawings.
So basically it's just
Can we put it in the,
like
can we do it times the numbers after we find it?
And then I would take it times 1,000, yes. Or add 3 zeros. Got it, Jordan? Samira?
Not yet.
Georgia?
What'd you say?
Georgia?
Go, 33,897,414.
Perfect. Oh, more. People?
People.
Perfect. Does say about, so you could round that a bit. Remember, it is in thousands. Don't forget to do that, times 1,000. What is the approximate annual percent increase predicted by the model? Well, what percent is shown in our parentheses there? What percent is this?
10.31%. 103.
3.1%. Right, make it a decimal, add it to 1 like we've
Oh,
done.
I forgot to minus 1.
Yes, you did. 3.1% increase. What does this model predict for the population in 2017? Well, somebody needs to figure out how far 2017 is away from 1790.
227.
227? Again, that's 2017 minus 1790. So I need an answer there. Don't forget to take it times 1,000. It is in thousands.
4
Go ahead.
million. Ready? Alright, 4,090,505,700
All right, that's good enough. So 4 billion people. Is that accurate? No.
Why?
Current population in 2023, right now, is 373 million in the United States. So 4 billion is not accurate. We wouldn't be able to hold 4 billion people in the United States. What percent increase does a model predict each decade? Well, a decade is 10 years. So let's see what we get. Again, just looking at the rate to the 10th power. Okay, what percent is that? Okay, that is saying every decade we have a 36% increase in our population of our country. Suppose D represents the number of decades since 1790, write an equation in terms of D. All right, so I'm gonna write the same thing I just had. Except I'm going to take every decade times 10.
Why?
Because there are 10 years in a decade.
Couldn't we divide by 10? Could that be fine?
If you have 2 decades, Georgia, how many years is that? Took it times 10.
So we're still like finding this stuff.
We're not finding anything. You could also have used the other equation that you just found for 2a. Then you wouldn't have to take it times 10 because you figured out the number per decade, 36% per decade. So either one of those is just fine. If you use the year one, you gotta take it times 10 to get the number of years when it gives you decades, or you can just simply use that one. What percent increase does a model predict each century? Well, now we do the same thing with 100.
You want that answer?
I am waiting. I think somebody other than Georgia should give me this. So.
What?
I want this number, of course.
He had it the whole time, you just didn't say it.
Okay, good nonverbal communication. All right, if I make that a percent, guys, that is 2,118% increase every 100 years. Again, decimal 2%, move the decimals. Now you can see why that is not sustainable. Can't grow 2,000% every 100 years. 3B, write the equation. So you're going to do just like you did up here for a century instead of a decade. Georgia, what am I to multiply by now? 100 times the number of centuries.
Times centuries, wouldn't that be 100 times 100?
No, you're taking it times.
If it's 4 centuries, how many years is that? Okay, or we can use this equation that you just found here again. 1 plus that would be, what, 22? Again, either one would be fine. Oh no, that's including that. So this should still be 21.18. Is that what you're saying? Thank you.
Georgia?
Why wouldn't you have one because it's so?
We already included it, just like we did on this one. We just used 1.36. Keeping it the same. Question 3.
Oh, you're saying we already used it to find that percent?
Correct. Question 3, just matching here. So it's 6 years. And then you're doing semi-annually, monthly, every 2 months. One of these does not have a match. One of these on the right. And we'll have to write an equation for it. Started with $1,000, that's fine. Looks like you're adding here. So let's talk about semi-annually. Semi-annually, remember, is 2 times per year. So you'd have to take the interest rate divided by 2.
That would be number.
That would be what? That would be this guy right here. Why is there 12 there? Well, twice a year for 6 years is 2 times 6 is 12. So yes, that does match up with that guy right there. Next one, monthly. Of course, that means 12 times a year. So I'd have to take the interest rate divided by 12. Both of them actually go to that guy. This one is showing 12 times for 6 years. This one took 12 times 6 and got 72. So I need to write this one out. Every 2 months is how many times a year?
4 or 6.
6. So $1,000 times 1 plus interest rate divided by 6. Okay, so how many times does every 2 months happen in 6 years?
Well,
It's 6 times a year, you told me, for 6 years. 6 times a year for 6 years.
36.
36. 6 times 6 is 36. You can type in 6 times 6 if you want. All right, the Are You Ready here, I just want to take a minute and discuss that. You are investing $1,000 at a 5% interest rate for 6 years. Compounded every 2 months gives you this amount. It gives you 4 options. I would like you to choose one. Which one do you think would give you the best deal? Option 1, you increase the starting amount by $100. So instead of investing $1,000, you invest $1,100. Or you can increase the interest rate by 1%, so you make it 6%. You can go one more whole year, or you can have the interest every month instead of every 2 months. So which one of those do you think would be the best, in your opinion? And then I'm going to show you the numbers and see what you think.
So if it's a 5% annual,
Yep.
but
Every 2 months, you're getting the 5%. 6 times a year, they're giving you money.
oh, for 6 years.
For 6 years. Jackson, which one are you choosing?
I would say increase rate by 1%.
That's what you're choosing? Okay. So this would be the equation of the answer that they got. Percent happening 6 times per year, so I got divided by 6. 6 times a year for 6 years. That should be not 12. Should be 36. All right, so there's how they got their answer. If you increase the starting amount by $100, which one did you choose? Second one? So if you increase by $100, so it becomes $1,100, you get $1,483. So more, which we could expect. Increase the percent. So instead of 5%, I'm going to make it 6%. Everything else stays the same. That's the one Jackson chose. It's $1,431.
I'm kind of confused. Like, the 36,
6 times a year for 6 years. 6 times 6.
6 times a year for 6 years. Okay.
One more year. I thought that would be a popular choice. So 6 times a year for 7 years.
Just a reminder that there's a big blood drive in the hack today. And if
That's my
you
number.
donate, you just go to the hack with your ID.
35.
Thank you.
6 times a year for 7 years. 6 times 7 is 42.
I don't know why. Yeah.
Every month. So divided by 12. Now 12 times a year for 6 years. I'm not going to ask you anymore, Caleb. That's 72. So they're actually in decreasing order.
Wait,
This one, investing more money at the beginning, would be your best option. Anytime you're able to invest early in your lives, guys, do it. That is your best bet to make money.
how would not increasing not having the interest payment?
Starting with more money and starting to earn interest early is your best bet.
Yeah. But how? Okay, I'll just get that.
But it's okay, we don't need.
So, like the 12 times 6 is 72, where would you, I'm confused about that.
Monthly. 12 times a year for 6 years. 12 times 6.
How would that be the most though?
Wait,
Because you're doing it every month.
You are.
Divided by
And
It's more than this, but it's not making that big of a difference.
I don't know.
You made an extra 82 cents by doing it monthly.
Yeah, no. But
That's it.
I'm just confused how it wouldn't be more than the 1 year for adding one more year onto it because you actually have more reoccurring payments than you would with just adding one more year.
Right, but that's still twice a year. And it's still starting with $1,000. It takes you a long time to earn that extra $100. That's the difference. You're starting with more money. You're earning more interest on
I'm just talking
that
about the
initial.
last two, I guess.
Oh.
proved it.
I mean, that is proof.
Well, no, I just don't understand how because you got 72 times instead of
You can run the number, see how big of a difference that is. Just type this into the 72 power. All right, your assignment then, 416 to 419. There are a couple that are multiple choice, Samira. I'm going to point that out to you this time. Question 3 is multiple choice. You can circle the word all for that one, more than one answer. And 4 is multiple choice. I do want to point out this first one since it's 8 parts.
Yeah, I don't understand. I don't see the point of all.
Sorry, okay.
30% increase. Increase, remember you add to 100, right? So 100 plus 30 is 130. I'm going to use 1.3. That's all you do for that. If it says decrease, let's do D. Decrease, you subtract from 100. So 100% minus 2 is 98% as a decimal is 0.98. So that is all I'm looking for there. Increase, add to 100, make it a decimal. Decrease, subtract from 100, make it a decimal.
You should try.